There is a famous story about a man named Christian the lion. In 1969, two men bought a lion cub from a department store in London, raised him in their apartment, played with him in the streets, and eventually realized he had grown too large to keep in a city. They flew him to Kenya and released him into the wild through a rehabilitation program. A year later, they went back to find him. People told them not to bother. A wild lion would not remember two humans from a different continent. The lion had a pride now. He was living as a wild animal. There was no reason to believe he would remember them at all. They found him anyway, and when Christian saw them, he ran toward them, stood on his hind legs, put his paws on their shoulders, and pressed his face into theirs. He greeted each of them in turn. He introduced them to his pride, and then he walked back into the wilderness. That video has been watched hundreds of millions of times, and the reason it hits people so hard is not just because it is beautiful. It is because somewhere deep down, most of us did not expect it to be possible. We did not expect a wild animal to remember. So the question is, do animals actually recognize individual humans, not just in the moment, but for months, for years, across long separations? And if they do, what exactly are they remembering? The first thing to understand is that animal memory is nothing like what most people assume. For a long time, the scientific consensus leaned toward treating animal cognition as fundamentally simple. Animals were thought to operate largely on instinct, conditioned responses, and short-term associations. A dog was not remembering you, it was simply responding to familiar smells and patterns. A crow was not recognizing your face, it was reacting to visual stimuli in its environment. This view has been almost completely overturned in the last few decades. What researchers have discovered instead is that many animals possess memory systems that are far more sophisticated than anyone previously believed, and that individual recognition of humans is not only possible in many species, it appears to be actively practiced. Crows are perhaps the most studied example, and the results are remarkable. Researchers at the University of Washington conducted a series of experiments in which specific people wore distinctive masks while interacting with wild crows in a threatening way, trapping and handling them. They then observed what happened when those same masked individuals returned to the area where the crows lived. The crows scolded the threatening masks consistently, while ignoring or reacting neutrally to masks that had never threatened them. This alone would be interesting, but what happened next was extraordinary. The crows recruited other crows to join in the scolding of the threatening mask, even crows that had never encountered that person. They taught their offspring to recognize and respond to the threatening face. Years later, the same masks were still being scolded by crows that had never been trapped themselves, but had clearly learned the association from older birds. A wild crow remembered a specific human face for years, communicated that information to other crows, and the knowledge passed down through generations. This is not a simple conditioned response. This is social information transmission about a specific individual human face. Elephants take this even further. Elephants have the largest brain of any land animal, and a memory capacity that researchers are still working to fully understand. Studies conducted in Amboseli National Park in Kenya found that elephants were able to distinguish between the clothing and scent of different human ethnic groups, specifically identifying the Maasai, who historically sometimes threw spears at elephants, as more threatening than the Kamba people, who traditionally did not. But more than this, individual elephants that had had negative experiences with specific humans showed lasting behavioral changes when exposed to cues associated with those individuals, even after years had passed. Elephants that had lost family members to poaching showed heightened fear responses to human scent in general, something that researchers believe is passed down through matriarch-led family units, with older females teaching younger ones which humans, which places, and which smells to fear. The memory is not just individual, it is cultural, passed from one generation to the next, exactly like the crows. Dogs are the most obvious example most people would think of, but the depth of canine recognition goes further than most owners realize. Dogs recognize their owners not just by smell, which everyone already knows, but by face, by voice, by gait, and by a combination of subtle cues that they process simultaneously to build what researchers describe as a multisensory identity map of the people they know. Studies using brain imaging have found that when dogs see a familiar human face, the face processing regions of their brains activate in ways very similar to how human brains respond to familiar faces. Your dog is not just smelling you and triggering a conditioned response. It is recognizing you as an individual, building an internal representation of who you are, and updating that representation communication over time. There are documented cases of dogs recognizing owners after separations of many years, sometimes more than a decade, including dogs that were separated from their owners as puppies and reunited as adults, where the dogs still showed signs of specific recognition beyond what scent alone could explain. Dolphins are another species where the evidence becomes almost uncomfortable in its implications. In one set of experiments, dolphins were shown to recognize the signature whistles of other dolphins they had been separated from for more than 20 years. 20 years. In human terms, a dolphin was essentially hearing the equivalent of a voice it had not heard since childhood and immediately recognizing it. But dolphins also show individual recognition of specific humans they have interacted with. Trainers and researchers who work with dolphins over extended periods consistently report that animals they have not seen for years will respond differently to them than to unfamiliar humans, seeking interaction, showing signs of excitement, and in some cases appearing to remember specific games or behaviors associated with that person specifically. Horses have been studied extensively in this area as well, partly because of their long history of working closely with humans. Research has found that horses form detailed facial memories of specific humans and retain them for at least a year and a half, which is the longest gap tested so far in formal studies. But anecdotal evidence from long-term horse owners and trainers consistently suggests the real number is much higher. Horses that were sold or rehomed and later encountered their original handlers years later show behavioral responses that are difficult to explain without assuming genuine recognition. Their heart rates change. They seek proximity. They show behaviors associated with social bonding, rather than the cautious approach they would show with a stranger. There is something happening in those encounters that goes beyond simple smell recognition, and researchers are beginning to take seriously the idea that horses may maintain detailed long-term memories of specific individuals in a way that functionally resembles how humans remember people they were once close to. Sea turtles present perhaps the most surprising case. They are not warm, fuzzy, socially complex animals. They are ancient, solitary, and their brain structure is about as far from a mammal as a vertebrate can get. Yet there is strong evidence that sea turtles recognize the specific beaches where they hatched, returning to lay their own eggs decades later with remarkable precision. More relevant to our question, turtles that have been tagged and released by specific researchers at specific sites have been observed, in multiple documented cases, approaching those same researchers when they returned, displaying behavior that is not typical of their interactions with strangers or unfamiliar humans. Whether this constitutes something we would recognize as memory in a meaningful sense is still debated, but it suggests that even animals with very different cognitive architectures from our own may be tracking individual humans in ways we do not yet fully understand. Why does this happen? Why would so many different species, with very different brain structures and evolutionary histories, independently develop the ability to recognize and remember specific individual humans? The answer probably lies in the fact that humans have been a significant and consistent presence in the environments of many of these animals for a very long time. For prey animals, distinguishing between a specific human who has previously shown threatening behavior and one who has not is genuinely useful information. For social animals, like crows and elephants, the ability to share that information with the group multiplies its survival value enormously. For animals like dogs and dolphins that live in close association with humans, recognizing individuals is part of building the kind of social relationships that their environments now require. And for horses, the ability to remember a trusted handler versus an unfamiliar person may simply be an extension of the same social recognition systems they evolved to use within their own herds. There is also something worth considering about what the animal is actually storing when it remembers a specific human. It is almost certainly not a neutral photograph of a face. The memory is almost always emotionally tagged. Crows remember the threatening face because of what that face did, not just because of how it looked. Elephants remember specific humans in the context of whether those humans represented danger or safety. Dogs and dolphins remember the humans they have formed positive associations with in the context of play, feeding, care, and social bonding. The memory is inseparable from the emotional experience that accompanied it, which is strikingly similar to how human memory works. We do not remember people as neutral data. We remember them wrapped in how they made us feel, what we were doing together, what the experience meant. The difference between human and animal memory, it turns out, may be less about whether emotional tagging of individual recognition exists, and more about the complexity and detail of what gets stored. So when Christian the lion ran toward those two men after a year in the wild, what was he actually doing? He was doing what crows do when they teach their offspring to recognize a threatening face. He was doing what elephants do when they pass knowledge about specific humans down through family units. He was doing what dogs do when they wait by the door for someone who left 3 years ago. He was running toward the emotional memory of a specific experience with two specific individuals, and expressing something that, whatever we decide to call it in scientific terms, looked and felt to every human watching it like recognition, like memory, like joy. Animals remember the humans who matter to them. They remember them for years. They remember them across distances and separations that should, by any simple account of animal cognition, be more than enough to erase any trace of the connection. And they remember them, almost always, in the emotional terms that mattered most. Whether the experience was safe or dangerous, whether it brought food or fear, whether it meant warmth, play, care, or pain. The memory is always, at its core, about what the relationship meant, which, when you think about it, is exactly how humans remember each other too.